Predictive analysis is a data-driven method that uses historical data, statistical algorithms, and machine learning techniques to predict future outcomes. This approach helps organizations anticipate trends, identify risks, and make data-driven decisions. Predictive analysis focuses on forecasting what is likely to happen rather than just describing past or present data. Regression analysis examines relationships between variables to predict outcomes. Techniques include linear regression for predicting continuous outcomes, logistic regression for categorical outcomes, and polynomial regression for nonlinear relationships. An example is predicting future sales based on advertising spend and seasonality using regression models. Time series analysis analyzes data points collected over time to identify trends and seasonal patterns. Techniques include ARIMA for modeling time series data, exponential smoothing for reducing fluctuations, and seasonal decomposition for identifying seasonal, trend, and residual components. This helps in forecasting monthly electricity demand based on historical usage patterns. Decision trees split data into branches based on decision rules, helping to predict categorical and continuous outcomes. Classification trees predict categorical outcomes, while regression trees predict continuous outcomes. An example is predicting whether a customer will purchase a product based on their demographic and behavioral data. Neural networks mimic the human brain's neural structure to identify complex patterns. Techniques include feed-forward neural networks for pattern recognition and simple forecasting, and recurrent neural networks for time series predictions. An example is predicting stock prices by analyzing patterns in financial market data. Classification models categorize data into predefined groups based on predictive variables. Techniques include support vector machines for separating data points using a hyperplane, and k-nearest neighbors for classifying data points based on proximity to nearest neighbors. An example is classifying email as spam or non-spam based on historical labeled data.